All right, so we're going to start off by talking about just what are transformations. So when we think about the word transformation, we think about the word transform, and you know that transform means to change. So transformations that only change the direction of a figure produce congruent figures. So remember, congruent means same size and shape. Okay, so in order for two things to be congruent, they have to be the same size and they have to be the same shape. So if a transformation produces figures that are congruent or the same size and shape, they're called rigid motions. They do not change the size of a figure. They include translations, reflections, and rotations. So these are our three rigid motions. So we're going to talk about them first. An operation that maps an original figure called the pre-image, before image, onto a new figure called the image. Okay, pre is before, so your image is the actual, like, after the translation, after the reflection, or after the rotation. A transformation can change the size, position, meaning like the location, or orientation of a figure. So, a rigid motion cannot change the size, but a transformation can change the size because we have specific types of transformations called dilations that do change the size. So again, just to clarify this part, the size can be changed by a transformation, but not by rigid motion. Okay? So a transformation can change the size, position, or orientation of a figure. So we know what size is, we know position is its location, and orientation is how it's turned. So orientation would be like if we have a triangle facing up and we rotate it, it could now be facing to the right. So that would be the orientation. Okay, so vertically, so first let's talk about translations. So remember we had flip, turn, slide in like 5th grade, and a translation is a slide. So to vertically and or horizontally slide a figure. So we're just moving it. In symbolic form, if we have a coordinate x, y, then that coordinate is going to be x plus h, y plus k, where h represents the horizontal shift and k represents the vertical shift. This should look familiar to you because it is what we did with, it's very similar to what we did with vertex form, except for this time there's no like backwards rule to remember. It's just x plus h, so whatever's added to x shifts it horizontally, or if it's subtracted, it shifts it to the left. And then y plus k, so if something is added, it shifts it up, and if it's subtracted, it shifts it down. So let's practice with a few of these. Rectangle QRST with vertices of Q at -6, -1. So I'm going to go 1, 2, 3, 4, 5, 6, -1. So I'm going to label that Q. Make sure you label your coordinates. -3, 1 is R. 1, 2, 3. Oh, that's -3, +1. So 1, 2, 3, 1. That's R. S is at 1, -5. And T is at -2, -7. Okay, so now we have a rectangle. We can connect our dots. And so my rule is xy is now x plus 5, y plus 7. So we could do this two different ways. We could either take a coordinate and move it following this rule, X plus 5 would mean I move it to the right. 1, 2, 3, 4, 5. And then Y plus 7 means I move it up 7. 1, 2, 3, 4, 5, 6, 7. So this would be my new R coordinate, which if you count would be at 2, 1, 2, 3, 4, 5, 6, 7, 8. So I know that the coordinates of R prime are 2, 8. To show our image coordinates, we put this little apostrophe right here that we call prime. So R prime means the image R, so the after R. So I'm going to put R prime right there. Another way we could have done this is to take the coordinates of R, -3, 1, and said -3 plus 5 gives me 2, and 1 plus 7 gives me 8. So that will give you those coordinates. So if you would rather count with a graph or if you would rather just add, that's up to you. So then Q is at -6, -1. I'm going to go to the right 5, so -6 plus 5 is -1. And then it's the Y is at -1, so then I'm going to add 7. So -1 plus 7 is at 6. So -1, 1, 2, 3, 4, 5, 6. Now you should notice that Q and R are at the same slant as they were down here. If all we're doing is a translation, that should be true. So you kind of have a checkup on yourself right there. Then S, or S prime, is going to be 5 over and 7 up. So I could take S and I could count, or I could use my coordinate. So 1 plus 5 is 6. And -5 plus 7 is 2. So I'm at 6, 2. So that should be there. So that's S prime. And then T prime is at -2, -7 to start with. So -2 plus 5 is 3. And -7 plus 7 is 0. So 1, 2, 3, 0. Now, as we look at this figure overall, it still has the same orientation. It's still turning the same way. Okay? It still has the same size. The only thing that's changed is its position. So you need to remember that in translation, the only thing that changes is the position. All right, write a rule describing the translation below. So if I'm trying to find the translation, how do I know which one's the pre-image and which one's the image? You're right, the pre-image does not have anything on it, and then the image has this apostrophe right here. So this is the before, this is the after. So I'm going from this one to this one. Okay, so let's count. From D, it goes 1, 2, 3, 4, 5, 6, 7, 7 to the right. So let's count one more time. 1, 2, 3, 4, 5, 6, 7. So if it goes 7 to the right, then my rule is that what started as XY is now X plus 7. It's a plus 7 because it went to the right 7. And then from here, I go up 1, 2, 3, 4. 1, 2, 3, 4. So that should be Y plus 4 because it goes up 4. You could just do that from D to D prime. If you counted from E to E prime, it should follow this rule. F to F prime should follow this rule as well. So try the problems below to see if you've got it.